Good day everyone. In indefinite integrals, if you want to integrate some expressions where your numerator is a constant and the denominator is either a root quadratic or a quadratic not factorisable, you will be using some special 6 formulae and you will be doing. But for doing that sum, you should understand the concept of completing the square method. So today let me explain to you that concept, and then we will see in the next video how we will be using it in integration. So the algebra concept of completing the square method I will explain today by giving you 3 examples. Okay, that is, any quadratic expression given, I am going to express it as a sum of 2 squares or as a difference of 2 squares. That method is called completing the square method. Okay, so the first example I will take is x squared plus 5x plus 7. That is, I have taken the coefficient of x squared as unity. This is the first and simple example I am taking. So now, because I want to express it as some perfect squares, I will be using the formula like a plus b the whole square or a minus b the whole square. Based on that, I am now telling you what are the steps you have to follow. Now first see what is the coefficient of x here. That is plus 5. Okay, divide that by 2. Then you square this. Now you are going to get 25 by 4, right? So you take the coefficient of x, divide by 2, square it. Now this expression you write as it is without any change. You add 25 by 4 and you subtract 25 by 4. You know, when you add and subtract the same quantity, the expression will remain unchanged, isn't it? There will not be any change. So now I have done that. Now you combine the x square term, x term, and the positive square you have now added. Write the square root of this x. Write the square root of that 5 by 2. Here you have a plus sign. Put a plus sign. Write a whole square, right? Now this is like a plus b the whole square. You expand it, what will you get? Let us see. You will get x squared. You will get 25 by 4. The 2ab term will be 2 into x into 5 by 2. So you will be getting 5x. Only for that we have adopted that method there, right? Okay. So now I am getting. Now what are the terms left out here? 1, 7 and 1 minus 25 by 4. So let me write them. Plus 7 and minus 25 by 4. Write a 1 here. The LCM is 4. 4 into 7, 28. Minus 25, I will be getting 3 by 4. But I want to express it as a square. So you write it root 3 by 2 the whole square. Okay. So now I will get plus root 3 by 2 the whole square. Now this is the format I wanted to get. That is, this quadratic I am now expressing as some square plus some other square. Okay. So now you understand this. Then it will be very easy for you to know the sums based on this in integration. Okay. So now we have taken the simple one, that is the coefficient being 1. But always the coefficient is not going to be 1. No. It can be any number. So now let me take another sum where the coefficient of x squared is not 1 but it is some other number. Now let me consider an expression 3x squared minus 2x minus 7. Now as you can see, the coefficient of x squared is now 3. Now what you have to do is, the first step, take that coefficient out. Okay. So now you will be getting x squared minus 2 by 3x minus 7 by 3. Here you may get fractions, that is not a problem. Now what is inside the bracket resembles your first type, that is the first example I told you. Now the coefficient of x is minus 2 by 3. Divide that by 2. 2 means it is 2 by 1. You will be getting minus 2 by 3 into 1 by 2 reciprocated. I will be getting minus 1 by 3. Square it. You will be getting 1 by 9. So now let me write the 3 as it is. write the expression as it is, okay? Then within bracket itself you have to add and you have to subtract that 1 by 9. Now take the x squared term, take the x term, take the positive square. So now you will get 3 into the square root is x, the square root is 1 by 3. It has a minus sign, whole square. Now it is like a minus b the whole square. Shall we expand and see whether it is coinciding to the 3 terms there? X squared, 1 by 3 the whole square is 1 by 9. The 2ab term, you know the formula is minus 2ab. So 2 into x into 1 by 3. So minus 2 by 3x. Now the remaining terms are minus 7 by 3 and minus 1 by 9. Now the LCM is 9. So 3 will go 3 times. You will get minus 21 minus 1. So minus 22 by 9. Now let me write it as minus, I will write here, root 22 by 3 the whole square. So I will get now minus root 22 by 3 the whole square. So here you are getting some square minus some other square. So for this sum, when you have the coefficient, the only difference is take the coefficient out and then do as you have done in the first example. Okay. Now one more, even though that's not a very different type, I want to tell you what will happen if the coefficient of x squared is negative. Because in the 2 sums I have taken, the coefficients were only positive for x squared. So now let me consider one example where the coefficient of x squared is negative, so that it will be easy for you to do the sums in integration when it comes. Let me consider now the expression 8 minus 3x minus x squared. Okay. Here the coefficient of x squared is minus 1, but there is no need for me to write that 1. So I will just take the minus out. I will get x squared. Now the x term will become positive. The number term will become negative. Okay. Now what is inside your bracket resembles to the first example. So now the coefficient of x is 3. Divide that by 2, square it. So you get now 9 by 4. So minus is there. You write x square plus 3x minus 8 plus 9 by 4 minus 9 by 4. Right? Now as usual, take this term and this term. I think now you will be familiar what terms you have to combine. Minus the square root is x. The square root is 3 by 2. It is plus. So put a plus. Now the terms remaining are minus 8 and minus 9 by 4. Okay. 4 is the LCM, minus 32 minus 9, which is minus 41 by 4. Write the minus. Root 41 by 2 the whole square. Okay. So minus root 41 by 2 the whole square. So this minus is here. Now if the quadratic given in your sum is just a quadratic, you can do like this. But sometimes you will be getting the quadratic within your root. If it is within your root, this minus you cannot take out. So it is better you learn this way. Bring the minus in. You write it root 41 by 2 the whole square minus x plus 3 by 2 the whole square. Okay. This is the big. So I hope you have understood all the 3 examples. So let us see in the next video how we are going to use this completing the square method when we do sums in indefinite integrals using this method. Okay.